Welcome to Haltech Elite NSP Training Part 30. In this training module, we're going to be exploring using a mass airflow sensor for our fuel and airflow model strategy within our Haltech Elite systems. This is definitely a different approach than what we've discussed earlier in our other training modules looking at speed density style tuning using volumetric efficiency, fuel flow rate, or injection time base. So we're going to break down how all this works based on a MAF sensor as our input for airflow. Without further wait, let's jump in so we can check this out.
Okay, so let's get started. We're going to be taking a look at working with a mass airflow sensor in our fueling and airflow strategy. This is going to be something that I like to work with here with the Haltech whenever I get a chance. A lot of vehicles are getting rid of the mass airflow sensor. They're actually a great way to calibrate and tune your vehicle, and you can find you can get them dialed in very quickly with a mass airflow sensor. So we're going to talk about what the mass airflow sensor is going to represent here, why you might want to work with it, and then how we set our Haltech up to actually include that MAF sensor in our airflow model. Now, the beginning of the tutorial here, let's just quickly recap our speed density volumetric efficiency model, because it's very similar when we're dealing with a mass airflow sensor in terms of our airflow and our fueling strategy. So let's quickly just recap our VE style strategy here. So we know that we have an underlying equation. Fuel mass is equal to air mass divided by target air fuel. So we'll find that the air mass is estimated and represented here from our VE values of our table. We have to know MAP sensor, we have to know intake air temp sensor, the number of cylinders, engine displacement, and then finally our percentage of cylinder filling. Here, we put all that together into an equation, and then we'll output the estimation of airflow or air mass. And we'll find that once we know the estimation of airflow, we divide it by the desired target lambda target air fuel coming from our target table. We'll then be able to calculate what the fuel mass is going to be. We convert the fuel mass into an injector pulse width by knowing the injector slope or the flow rate, and then adding on the dead time or the latency, and then also adding on the short pulse width. So we get a total corrected injector pulse width that we send to the injector. If everything's right within the fuel and airflow model, we'll find that we will hit that desired target air fuel and that everything is going to fall in line. So any changes that we need to make, let's say we change our injectors, we can simply just enter in the new injector data, assuming it's accurate, and we don't have to retune the engine. If we've changed the displacement, we don't need to retune the engine. We can simply enter those specific parameters in to our configuration settings here for the Haltech. It'll take care of the rest. So if we're changing things that are airflow based, such as camshafts or a turbocharger or supercharger, well, then we're going to need to do a retune. But once we've accounted for all of that, everything will fall in line, and it's a really straightforward system to work with. And as we've talked about it pretty extensively now, you should understand exactly what it represents and it means. Now, when we're dealing with a mass airflow sensor, we are not going to be estimating the amount of airflow coming to the engine from a table like this, looking at percentage of cylinder filling. We're directly going to measure the amount of airflow being ingested into the engine. Mass airflow sensors are used by OEM manufacturers because it is going to be a simplistic way to represent that air mass. We don't have to calculate it. We can actually directly measure it. Now, the only downside to mass airflow sensors is that sometimes there's a bit of a lag factor between when they're registering the airflow in a steady state condition and we have a transient throttle event where we have a big throttle change and a big airflow blip. Sometimes they're not as quick to react in terms of the air mass representation, but we have transient fuel calculations here in our Haltech that can help us deal with that, so it's not so much of a concern. The mass airflow sensor is excellent at determining steady state airflow coming into the engine. A lot of OEM manufacturers run redundant calculations, so they'll have the mass airflow sensor as the primary means for airflow registration to actually measure the airflow. Then they use speed density calculations to estimate the airflow, and in a transient type of condition or any kind of big rate of change in movement in engine speed or throttle, it'll actually look at the speed density calculations so it has another point of reference to make sure that the air mass is being calculated right so that the fueling will be calculated right and the engine will run properly. Something like a Subaru or looking at a GM, they're examples of redundant speed density and MAF type of calculations that are going on. Now with the Haltech, we don't have that. We're going to be either choosing speed density or mass airflow. But the mass airflow is going to be, as you're going to find here, incredibly simple to dial in. Let's take a look at how we're going to be working with this. And just before we move on to that, I do want to mention, and as I was trying to draw a correlation between speed density and mass airflow tuning. So the mass airflow is measuring the airflow. We'll know what the target lambda target air fuel is coming from our table. We'll figure out fuel mass. We still have to enter in the injector data, so the slope offset, flow rate data, the dead time latency data, and the short pulse width data. That'll convert that to a pulse width and deliver the fuel to the engine. We'll find that everything will be the same between a VE strategy and a mass airflow strategy. The primary difference.
Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here. And you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.